Assalamu alaikum. This is Dr. Usman Sadiq Paracha, and we would be having our lecture number 20 of the subject Applied Quantitative Analysis and Practices. Previously, in the past few days, we have been discussing about the factor analysis and the various stages we have gone through in this case, and what are the rules of thumbs in this case, because in every stage there are certain conditions, there are certain rules which need to be followed, and as we have discussed before, that in factor analysis we are basically trying to discover the pattern which may be lying within a group of questions or items of a specific model. So in order to do so, we have to go through certain stages, and here it's very vital that all the conditions for all these stages must be fulfilled in every case. So here previously we discussed about the rule of thumbs for factor models and the number of factors which can be extracted. Then we discussed about the processes of factor interpretation and the facts related to the factor rotation, and then there were certain methods related to the rotation of factors here, and then we had a brief outlook on the significance of factor loadings. Then we interpreted them, and then ultimately we have to derive the factor matrix. Again, all of these we would just have a go through these factors in a brief recap as we have done it in the previous slides. So here we would also go through the implementation of all these steps in SPSS today. Now, coming to the previous rules of thumbs which we discovered, as you can see here, basically we were focusing upon the two methods, the component factor analysis method and common factor analysis. And in here, we just discussed that they may report similar results pertaining to certain conditions which we had discussed before. Then likewise, again, how many factors can be extracted, and we have discussed here that the factors with eigenvalues greater than 1 and can be extracted. Then again, there can be factors extracted based on the theoretical background, and based on that again the percentage of variance can also explain these factor derivation from there. Then again, we had discussion on the processes of factor interpretation and how to estimate the factor matrix, and then how to rotate it, and then the factor interpretation in this case. And then if we have to re-specify the factor model, what decisions we will have to take, and based on that then we moved upon another important topic which is termed as factor rotation. Now factor rotation here is basically based upon the rotation of axis of factors, and here basically it is more clear from the diagram. Basically there are two types of rotational approaches which are done. One is the orthogonal approach and the other is oblique approach, and here as we can see in this diagram here, in this case this is pretty vital that we have got a few variables here, and these variables either load on one factor or second factor, but here as you can see in this diagram, in this case this is very much clear that we have got two variables here, v1 and v2, and based on their location here it seems that they are more getting loaded on the factor 2 here, which is represented here on y-axis, and the V3 and V4 are loading on factor 1. So anyhow, based on the factor rotation, basically the axis of the basically whole setup is rotated, and this is ensured that the difference between x and y-axis should remain 90 degrees. Now in this case, by rotation of these factors, we try to make these variables get near to their relevant factor axis there, so that their relative position becomes more clear and evident, and it is less confusing in this case. We will have a detailed discussion on it when we would be running the analysis, and then you will get to know about the whole specification in detail. But this is the theoretical justification of the whole phenomena which is carried out in SPSS. So here, like coming to this part back, let's have a look at the next one. This is the oblique factor rotation. Basically here the difference is a bit evident here, because unlike the previous method, here the two axes have been rotated, but there is no 90-degree angle which is existing in between the two axes. Again, by rotation of these two axes, the variables here get near to these axes here, and likewise the variables here V3 and V4 get near to the x-axis here in this side, which basically, when we are trying to measure these variables with reference to a certain factor, they give us a clear indication that which variable is attached to which factor in this case. So that is why oblique factor rotation is used, but we will be having again a detailed discussion on it later on. Then again we have got certain methods for orthogonal rotation methods, and we have got three methods here. In this case, one is Cortimax, second is Varimax, and third is Equimax. Now here basically in Cortimax the rows basically are simplified, and in case of Varimax the columns are simplified, and Equimax the whole combination is simplified. Now let's have a look at a typical example here, and in this case let's go to SPSS here in this case. Now here we are taking a data set in which the same one which we had discussed before, in which we were discussing a questionnaire which was related to the constructs of training, performance appraisal, career planning. Then like similarly here, if we click on variable view, we can see that here all the variables relevant to the training variable, and then all the variables related to the performance appraisal construct, likewise the variables related to career planning and employee participation and job definition, including compensation, are listed here. Now we have got the whole variable part coded here, and we can look at the data view. If we click on that, we can see the data which has been entered against each of the variable which is listed here. And here you can see that in this case we just want to find out the pattern of any structure which may exist among these variables. Now here again, though we theoretically know that, let's say, the 6 questions of the training variable should be related to the training construct, and the questions related to performance appraisal should be related to the performance appraisal construct, but we would try to apply exploratory factor analysis just to reconfirm and to say hypothetically that, let's say, we try to find out the structure if we don't know any specific know-how of any kind of construct which may exist among all these variables which is listed here. So here basically in this case what we have to do is just click on analysis, we go to dimension reduction, and we click on factor. Now here again you can see on the left side we have got a whole list of variables which can be seen here. Then again if we right click on this table, we can see that we have got a drop down menu in which we can get the display of these variables by their names or through labels. So it's up to you whether you go for names or labels. So let's say I click on only I let it remain with labels just for the clarity of the audience, but normally we do prefer to stay with or stick with names here. So here let's see, we just want to select the various variables, so we click on training variable 1, training variable 2, 3, 4, 5 and 6. We just click on the arrow here in the middle and we just keep on selecting the variables which are being shown in the box which is adjacent to this one in which the whole variables are listed. So likewise we just try to click on the variables related to performance appraisal. We click on it and we keep on selecting all of them. So once we have gone through the selection of all these performance appraisal variables, then we go on the career planning one. Likewise we select all of these variables here, and similarly then we click on the employee participation variable here and we select all of the 3 questions here and the job definition ones. Likewise we click on compensation and we click on them. Now here we have got basically the whole list of the various constructs which we used in that specific questionnaire, and we just want to test whether this as a whole, all the variables as a whole, do they represent any specific pattern or any specific structure which may exist. So hypothetically, if we are assuming that we don't know about any association of any variable with any kind of construct, then we just want to know whether which variable would be associated with which kind of construct in this case. So first we have to basically mention that what kind of results we are expecting from SPSS here in this case. So here let's say we click on descriptives, and here you can see that we can have univariate descriptives which would give us a descriptive analysis of all the unique variables which are enlisted here. Then we have got an initial solution, and then we want to have coefficients of correlation matrix reported. We also would like to know whether there is any significance level here. Then we are dealing with the determinants of the correlation matrix, which are the various figures involved in it. Then, as we have discussed before, that we would like to have the result of KMO and Bartlett test of sphericity. Now KMO basically gives us the idea whether the structure or the number of questions or the questionnaire items, do they have enough intercorrelations to justify the running of factor analysis on them. Likewise, Bartlett's test of sphericity also gives us the important measure of sampling adequacy, and in order to ensure that we basically have this measure of KMO and Bartlett test of sphericity significant, and not only significant but also above 0.5, we click on this option to know the result. And here then we have got another option which is like inverse, in which only the inverse correlation matrix is reported. Then we have got another one which is called reproduced. Now here in this case, reproduced option just gives us a correlation matrix based on the model, and it's basically based on the model and not on the real data. And then we are basically given a difference between the real model and the observed data, and the difference between these two is termed as residuals. Now these residuals basically should not lie above 0.05. So that is a summary of residuals which is generated by SPSS in this case, and which should not violate the maximum option. So here the other option is anti-image here. Now anti-image basically is a matrix of covariance and correlations, and these matrices contain measures of sampling adequacy for each variable along the diagonal and the negatives of the partial correlation on the off diagonals. So basically like the off diagonals should be very small, and the diagonal elements should be greater than 0.5. If they are not, then we have got a problem there. So we just click on continue, and we have mentioned the various descriptives which we want to know. Then the other important part, as we know, clicking on extraction, now we have to basically show which kind of analysis. So which type of analysis basically we have to select for our factor analysis here. So here you can see with the method option we have got the default option as principal components. If we drop down the menu, we have got several options here. One is principal components, the other is unweighted least square, generalized least square, maximum likelihood, principal axis factoring, alpha factoring, image factoring. So here basically as we have discussed before, and if we go back to the slide here, the thing basically which we discussed before about the two various methods basically in this case was related to common factor analysis and component factor analysis here, which you can see when you are discussing about the component and common factor analysis models. Now here, once we are mentioning the component factor model, that means we are talking about principal component analysis, which we have just seen on the software in the screen. And then there is another one which we were discussing here with the name of common factor analysis. Now this methodology is basically related to principal axis factoring, which is also termed as PAF. So here you can see, if we go back to the SPSS option here, you can see in the method part we have got principal component analysis, and then we have got principal axis factoring, which is basically representing common factor analysis method. So here basically now we have got two options under this, like in analyze, we can analyze it by either using correlation matrix or covariance matrix. So what's the difference between these two? Basically, if the variables which you are entering in your data set, if those variables have got different measurement scales, like you are measuring one variable on the basis of 7-point scale, and then the other variable is being measured by 5-point scale, that means that you have got difference of measurement scale among all these variables. So once the measurement scales are different, then it is important that we have got a standardized matrix for correlation which should be reported. So in that case we click on correlation matrix, which is ideal for giving us basically the values which are standardized, which can be compared among other data sets also. However, if the measurement of scales which is being used to measure various variables or items in the questionnaire, they are the same, then in that case we don't need the correlation matrix. It is better than then we can shift on covariance matrix here. So basically, in other words, covariance matrix is focused specifically when we have got same measurement scale among all other variables. But normally correlation matrix is preferred because of its advantage of being compared easily among all other data sets, and again also the interpretation of the results of correlation matrix is a bit more easy in this case. So this was the explanation of which analyzing method can be used under principal component analysis method. Then we have got another option adjacent to analyze, and that is display. Now here one thing is being shown here which is termed as unrotated factor solution. Now here unrotated factor solution means that we have not performed any factor rotation. If you can remember, we discussed about the factor rotation in our previous slides, that what was the factor rotation, but we will have a detailed look on it again when we see the result of this factor analysis being generated in SPSS. Now here unrotated factor solution basically represents the solution which has not been manipulated, which has not been rotated. Then we have another option which is termed as Scree Plot. We have already discussed about Scree Plot here again, and in that case this is one methodology to extract the number of factors which may represent the items of questionnaire. So in this methodology we basically use the help of the graph or plotting in order to identify how many factors should be extracted from the data set. So we click on it to select it. Then there is another method which is used for extraction, and that is based on eigenvalue. And here, as you can see, it is by default selected here that like based on eigenvalue, and eigenvalue greater than 1 will be the criteria for extraction of factors. However, you can give fixed number of factors here by clicking on it. If we click on it, then we would have to mention how many factors the SPSS needs to extract. But this option can only be used when we have basically some theoretical background which does indicate that certain items on the questionnaire are related to these many groups. So once we have got strong theoretical support to basically justify our group formation, so in that case we give the SPSS this option in advance, that these are the number of factors, a fixed number of factors which need to be extracted from that data set there. Then is another option here. By default for now we click on based on eigenvalue, and afterwards then we have got another line which is stating maximum iterations for convergence, and that is 25. That means that SPSS basically will run this whole test 25 times and will try to seek any kind of errors while running this test again and again. So normally 25 iterations are used, and that is enough for validating our findings for these factor generation. Then once we have gone through that, we click on continue, and we have given all relevant details related to extraction point. Then we are related with the rotation part. Now here again you can see that by default no method has been selected, but it is advisable to select one method which can be used to rotate the whole factor solution. Now in this case we already know that rotation basically helps us in defining the variables which are loading on various factors. It helps us in defining those factors more clearly. So that is why there are some different options here. One is Varimax, second is Quantimax, third is Ecomax, and then there is a Promax also, and then there is direct complement. So here basically Varimax is normally used, because in this case every value which is reported under the factor loading is maximized so that they must load on one factor or another. So Varimax basically is the implementation of factor extraction on columns, and that is more effective than Quantimax or Ecomax here. Now in Quantimax, basically we are only focusing on the maximizing of values along the rows, now which is not that much effective in result declaration. So here in Ecomax case, basically it's a combination of both, but again it has not been able to get itself popular that much. Then we can click on the loading plot if you want, the loading plot which we have discussed before regarding our factor analysis theoretical part. So we click on continue here. So coming to the next part, basically here we can click on scores, and again the scores can be generated for each question, each group basically, or each factor, and basically we can save them as variables as well. But once we have to save them, then we can use various methods. One is regression, second is Bartlett, the third is Anderson-Rubin. Now here, if in regression basically, and also in Bartlett, the groups basically, or the factor scores formed are correlated to each other in this case. However, if we want such factors that which are not being related to one another, then we can save the variables using Anderson-Rubin method. So here basically also we can get the factor score coefficient matrix displayed, the details of which we will discuss afterwards. So for now we won't click on any of these options because we don't want to save the variables in any form. So we click on continue. Then we go to the other option, which is termed as options, and here basically we can exclude the cases listwise. For missing values, again this is the same formula which has been used. So the same formula which has been used previously, and then in case specifically related to descriptives there. Now it's up to you whether you want to exclude cases if there are missing values listwise or pairwise, or you want to replace the missing value with the mean of the variable field which is within which that specific case is lying. Then we have got a coefficient display format. Now here the coefficients which will be displayed, the factor coefficients, can be sorted by size. So we click on this one, and again basically the Spss is asking if it can suppress smaller coefficients in rotated solutions. So there in that case we just click on suppress small coefficients, and here we have to give the absolute value below which these basically coefficients will not be considered here. So we say that 0.30 basically is the standard formula for the absolute value which should be the benchmark for suppressing small coefficients. So clicking on continue, we have basically mentioned all the commands which are necessary for running factor analysis in this case. So we click on OK. Now here we can see in the output window the results of the factor analysis for which we have given descriptives. Now here you can see the correlation of the various variables with each other, and here basically from correlation perspective it is clear that there are strong correlations among certain group of variables and there are weak among others. So the groups which have got strong relationship with each other are then extracted, but correlation basically gives us a brief idea of the real-time situation which may be resting in the data. Now here then we are dealing with the significance of the values one-tailed, whether they are significant or not, and as you can see that many values here are termed to be significant here. So here, once we are satisfied with the correlation, so this correlation basically gives us a detailed view of the nature of relationship between these various items with each other, and we can also judge very clearly from here that which correlation is significant and which is not. Then we have got another window which is headed by the heading called KMO and Bartlett's test. So these are the same tests which we discovered before, and here basically KMO basically is the measure of sampling adequacy, which is 0.753. So it is higher than 0.5, and it quite justifies basically the minimum value which is required for all these variables to be interrelated with each other. Then we have got Bartlett's test of sphericity as an additional test, and here again it is termed to be significant. That means that sufficient correlation exists between these variables. Now here in this case, once we have a look at the anti-image covariance, we can see that the values at the diagonals, like the first one is 0.526, then we have got 0.360, then 0.356, and then last but not the least 0.242, 0.333. So these are basically the anti-image covariance which are being reported here, and they should show the value above 0.5. Otherwise they won't be considered here. So here, based on that, anti-image correlation has been tested and has been shown here, and you can see that in this case some pattern is beginning to emerge from all these values. Now these anti-image correlation values which are at the diagonal clearly depict that their values are greater than 0.5, so this is a viable option here, and they satisfy the criteria. Then we have got another group of variables whose values are reported under the heading of commonalities. So how much common variance each variable is sharing with other variables. So here you can see in case of training variable 1, it has got basically the common value reported as 0.627, which is good enough. Then in case of variable 2, we have got 0.734. Then for 3, we have got 0.692, likewise 0.802 here, and so on. So all of these values which we have seen here have been reported under the extraction method of principal component analysis, and here you can see that nearly every value is above 0.5. So that makes an ideal case. Then let's say we cannot solely rely on only one method to explain the variance among variables. So here we apply another methodology based on eigenvalues, and here we can see that all the components are selected, and here the variance, individual variance of each variable is enlisted here, with the fact that percentage of variance is also mentioned. Then we have to calculate the cumulative of all these variances. So here you can see that again the initial eigenvalues have again been transformed into extracted sum of squared loading. So basically here you can see that the total values listed here are these, and then we are basically mentioning the variance here, percentage of variance. Now these values are around about the same. However, the cumulative percentage would be increasing. So here you can see the cumulative percentage, which was 18.7 at first, and second time it was 35.03, and then so on, it keeps on increasing. with the increase of any individual variable value in this case. So we have got total variance explained here, and in this case one is for sure that how much cumulative percentage all of these values above 1 are basically considering. So here you can see that there are plenty of values which are above 60 as well and less than 60 as well. So the less than 60, like 16 and 35, need to be dropped by in this user basically, so as to ensure that the data is unbiased. Then we can check the same distribution through Scree plotting, and here in Scree plotting you can see that all the values are coming at the downward direction, and then suddenly they take another turn and they get vertical in this case. So we basically are trying to find the influx point in which there is a break of the line which is at the start, which we can see on the graph with high component number and high eigenvalues as well, but then there's a middle way in which middle point here in which we have divided the region into two parts. So here basically in this part, this is the one way to separate the groups which contain some meaning. So next here in this analysis is the component matrix, which is being shown here, and as you can see here that in the initial component matrix, without applying any kind of other test, these are the factors which are basically mentioned here with the numbering, which is 1, 2, 3, 4, 5, 6 and 7. These are the factors which are being considered, and in this the first one has basically shown basically similarity, and also it is showing that career planning and performance appraisal may be in fact related to each other and they may be measuring the same thing. But here you would have to see basically in reality that these variables in reality, are they the same concept, theoretical based, or in theoretical based arguments? If they are not, then we would be going for the option which is termed as rotated component matrix. Now here the simple component matrix is one is not able to show you a very significant pattern or a correlation among all these variables. So this is vital that then we apply factor analysis in order to have the complete idea that which variable is leaning towards which side or which factor in this case. Now here, based on the component matrix which we are seeing here, it doesn't make much of a sense. Some variables are though attached to the variable or the data set which does represent them, but the other are totally irrelevant to the definition which we have discussed before. So here, once we have basically extracted the various variables, then we are dealing with the reproduced correlation. Again, as we have discussed before, that in case of reproduced correlation, we basically are dealing with a correlation matrix based on a model, and the matrix based on the model and the matrix based on observed data indicate the presence of any kind of residuals within the model, which should be tried as which should be termed as minimum. And here in this case you can see the residuals of the relevant analysis have been displayed here, and in this case you can see that most of the values are less than 0.05, which is the benchmark for having good standard errors in this case. So based on that, this has been generated for each and every in each and every case. So basically, once we have gone through that, then we come to the diagram. We have discussed this in detail, And as we have discussed before, that normally in terms of very complex data, these 3D diagrams just showing the factor analysis would become irrelevant in this case. So here basically we had not mentioned any specific type of rotation method which could have been tested here. So here we can basically run an additional analysis in which you can say that we can run the rotated component solution there on this aspect as well. So here going back to the theoretical part, here you can see the things which we have been discussing here, and in this case we have already seen that the eigenvalues which are greater than 1 and how they have been discussed in SPSS results, and then how the specified percentage of variance which is 60% or higher has been used as basically benchmark to know how many factors can be extracted. Now this factor basically can be seen again in SPSS, which you can see from the result here, that initially in this case when we have a look at the SPSS results, then we can see that basically the total variance explained, which you can see on the screen here, that's an important part, because initial eigenvalues have been reported, but they are not of that much important as compared to the extraction sums of square loadings. Now here in this case we have to see that normally minimum number of factors should explain 60% variance of all the model. So here you can see that on in observation 5 here, the basic cumulative variance here is 62.48. So basically at this stage the number of factors behind that can be taken for further analysis, as it justifies the 60% percentage variance rule. So as we have discussed before in the slide, these rules are considered for selection of viable data, which can help us in basically streamlining the complex procedures in data calculation. Now once we have gone through that, we discussed about the Scree plotting. We also discussed about the latent root criterion. So latent root criteria basically is related to all these components and this total variance explained table, and in this basically you can say that the values which have been reported here would be following the same limit as before. So now here basically once we have gone through the Scree plotting, and we have also used this method to identify whether how many members of items basically, or items should remain in a specific group. So based on that, again the latent root criterion, which has been discussed before, is the same criteria which has been followed for ensuring 60% explanation of all the variables for a model. So here basically the total variance which has been explained is explained from that perspective here. So now coming to the third part, which is related to component matrix. Now component matrix basically is enlisting the factors, those factors which have value greater than 0.3, as you have discussed before, that in options part in that main factor analysis window, when we click on it, we are given the option that at how much level should the values in a factor analysis part should be considered as sufficient in this case. So basically in this case the component matrix gives us a brief overview, and here we can have a look at the SPSS also, because in this case in fact just have a look at the slides which can give us a faint idea. So basically here you can say so that all these variables, though, are showing some kind of relationship among them, but this pattern is not that much clear. That's why we use rotated matrix solution, because it rotates the values with their respective axis in such a position that these values are easily connected to any other kind of relevant authorities. So basically, in this case, once you have gone through that, then we are dealing with reproduced correlation. So here you can see that in reproduced correlation we are given the relationship which are basically among the variables shown, and in this case you can see that these reproduced correlation are wholly solely based on the ideal model, which is shown in the shape of straight line. But again, reproduced correlation is not completely out of biasness. So here we also use the residuals. We calculate the residuals from this data by comparing the actual data observation with the ideal data formulation. So while subtracting both the values, we can get the residual, and we try to see whether if there is any kind of notable difference in between these two. So in this reproduced correlation, and after seeing to the residual, we can see that very few values are above 0.05, which is a notable exception. So we can accept all the values in this case. Once we have got the residual in our hand, then we can see that the component basically plotting basically has been done in this case here. So coming to the real part, basically, that if we do want to test basically after following certain methodology for rotation of solution, then we click on dimension factor, we click on rotation, and we click on Varimax. Now here, as you have seen, that after rotating the matrix, these values would fix themselves to a more favorable factor. For example, you can see here from this perspective that the component matrix which is being shown here, we can see that quite a number of variables are attached to group number 1, the factor group number 1, and the more than values which are in one column are listed in factor 2. And then again, the values, the empty columns which you can see here have been eliminated, because as in options part, I have already mentioned to SPSS to suppress any small coefficients which are reported below 0.3, because it doesn't make any sense. So those values which are above 0.3 should only be reported. So that's why in all these columns you can see the empty places, which basically gives us the idea that many values are below 0.3 here in this case. So once we have gone through that, then coming to the factor analysis part, we have basically 3 methods for rotation. And here you can see, while going to the slide, that in rotation part, basically there are 2 types. One is orthogonal, the other is oblique. Again, these approaches are not specifically used as the same name from the literature, but rather changes are made in renaming these approaches as well. So just to get the idea of how to rotate the matrix, we can easily see that these 2 values, variable 1 and 2, are basically showing much higher affiliation with factor 2, which has not been rotated now. Now here, though these two variables are unable to give us a clear picture that which variable is exactly more closer to the factor 2, unrotated factor 2 axis. So here basically in order to solve this issue, the axis, relevant axis have been rotated to facilitate the easy interpretation of the variables which result from this analysis. So these factor rotation methods are important, and in this case let's say the Varimax basically methodology has been seemed to be more effective than the other two termed as Equimax and the Quantimax there. Reason being so that in Varimax option the columns value are basically increased in to such an extent that they clearly tell us that on which factor model they are rotating to. So the pattern making as a result of this whole exercise becomes more interpretive, more conclusive in this case. Coming to the SPSS part, let's have a look at the results. As we see that we are now mentioning the Varimax method for rotation, then we click on continue, and here we can click on OK. So again the results have been generated. We already know the values and the significance. We can see the KMO value for the whole data set is 0.753, which is significant as well. So on the whole, basically we can say that this whole factor analysis can be deployed in order to measure the various pattern of data within this group set. So coming to the various tools like anti-image covariance and then anti-image correlation, we can see that the values are satisfying all criteria which has already been discussed in slides before. Then we had a look at the commonalities, and we can see the commonalities, all of them are above 0.5. That is that the shared variance among all these variables is around about the same or higher than 0.5. Then we had the total variance explained, and we came to know how to basically extract the factors based on the eigenvalue or the percentage variance which you can see here. Once we have gone through that, then we can also use Scree plotting, which is evident from this screen, and based on that then we have got component matrix, which we have discussed before, and in this case it is pretty much evident that all these values basically are not clearly identifying a pattern, because unusually all the career planning, performance appraisal items are all loaded on one factor, but based on theory all these items should be basically separately loading on each separate factor, because each question represents a totally different entity here. So let's say we just basically rotate these, and after rotated component matrix you can see that a more clear picture of which items are related to which group have now been seen, can now be seen here. You can see that factor number 1 entails career planning item, basically construct. Then likewise factor 2 represents performance appraisal items. Then we have got in factor 3 we have got the training item enlisted here. Then we have got compensation item, which is enlisted in group 4, and likewise employee participation basically component, which is represented by 3 questions. So all these values typically represent and exactly basically gives us a more better picture of the affiliation of various variables with their construct. So it is a bit advisable that we should employ this methodology, rotated component, in order to have a clear picture of which variable is related to which factor group in this case. In this lecture, we basically had a brief overview of the concepts which we had studied before, and then their relative application in SPSS as well, how to apply them, how to give their assumptions, how to specifically mention the conditions which needs to be fulfilled while applying the concept of factor analysis in data. So once we have gone through that, the relevant results were generated, and then we had a discussion on how the results are to be interpreted with relevance to their real-time setting. And based on that, we had a brief discussion on how to interpret the rotation of factors and how to basically mention and choose the various options available under the rotation of factors like Varimax, Equimax, and Quantimax options. Likewise, how we can interpret the factor loadings and the commonalities which have been displayed. We discussed in detail the concept of anti-image covariance matrix, and then its application and how we can see the various options through which we can ensure that these values fulfill the criteria. Based on all these, we had a test on a pilot study which has been conducted on the same questionnaire which we have been discussing before. We hypothetically assumed that all the items within that specific questionnaire are not related to any constructs, and their relationship to any specific constructs is not known, and we just want to find out the structure and pattern among all these variables so that we can know which factors represent these values. So based on that hypothetical example, we just ran a test, and we would be further running the factor analysis extension test on these, and we will be discussing these in future lectures also. Thank you so much. Allah Hafiz.